Kia ora, it's Mr. Dharma, and today we're going to talk about integrating functions. Let's go straight into it by looking at exponentials. So exponentials had a wonderful derivative, and we're going to just build on that. So consider this function, f of x is equal to e to the x. Its derivative was also e to the x, and that was really exciting for us. And so it also works backwards. So if I gave you a function, dy by dx was equal to e to the x, if I were to integrate it, the integral of e to the x is e to the x. But remember from the last video that every time we integrate, we must plus c. I don't think that's too hard. So let's try the next function. What about trigonometric functions? So let's consider f of x is equal to sine x. It differentiated to cosine x. So if we had dy by dx is equal to cosine of x, the integral would be backwards, sine, plus c. Remember, every time we integrate, we must plus c. And so your whole table of derivatives, you can now just go backwards, making sure you do plus c. Similarly, dy by dx of negative sine integrates to cosine plus c. And that plus c is going to be fundamental for us in all of what we do. And then consider logarithms. Logarithms were really exciting because we were able to differentiate them to nice functions. So ln of x differentiated to 1 over x. And that was really exciting for us. So let's try this backwards. If dy by dx was equal to 1 over x, y is ln x plus c. Remember, c is very important. You know, every question will need us to do plus c. So, how do you make this harder? Well, you take these functions and you look at stranger versions of them. So what about dy by dx is equal to e to the 2x plus 7? Well, if you integrate, the e stays as is, so it's e to the 2x plus 7, but instead of now multiplying by the derivative of the inside, we're dividing by the derivative of the inside as our bracket rule, plus c. Similarly, if dy by dx was equal to cosine of 2x plus 7, its integral is sine of 2x plus 7 divided by 2 plus c. Similarly, if dy by dx was equal to negative sine 2x plus 7, the integral would be cosine 2x plus 7 divided by 2 plus c. Also, if we came back to here, if dy by dx was equal to 1 over 2x plus 7, then y is equal to ln of 2x plus 7 divided by 2, because the derivative of the inside is 2, plus c. And that is not so bad. But the question still comes along. Why does the inside function need to be linear? And that is really, really important. Let's have an example where the inside function is not linear. Okay, so I'm going to do this in red because it's wrong. Okay, if dy by dx was equal to e to the x squared, and I integrated this to e to the x squared over 2x plus c, if I were to redifferentiate this, I would need quotient rule. But since I didn't use some sort of reverse quotient rule to get there, this must be wrong. So the inside function must always always be linear, and that's super important. Right, so now you can differentiate exponentials, trigonometric functions, and logarithms. Good luck, I'll see you in the next video.